Our final year project topic is the system application of the Internet of Things, and we would like to build a smart pet house. Why we will have this idea? Recently, the citizen of Hong Kong is not easy to keep a pet because we always need to work during daytime. Most of the hosts will leave plenty of food and water, which sounds make sense. However, it may cause the overtake of food, and sometimes the water may not be enough for the dog. Besides these physical needs, dog needs care. They need to play with the host, and it is not easy to handle if it steps on its excreta and walk around the house. After realizing this problem, we do some research on smart dog house, but we find that the recent products are too well prepared that almost replace the host. Therefore, we aim to build up a smart pet house that can help the host but not replace the host, and those hosts who doesn't have the housekeeper. This project can be divided in 5 parts, which is food feeding, water refilling, toys, toilets, and real-time camera. Talking our methodologies, at this stage we have used Arduino and XP. Arduino is an open-source prototyping platform based on easy-to-use hardware and software. It's able to read inputs such as sensors, buttons, and turn it into outputs such as activating motor or turning on LED. Arduino has different types of board. In our project, we mainly use Arduino Nano and Arduino Uno, where Arduino Nano is used to handling the sensor message transfer, and Arduino Uno is to use to connect to the network. About XP, XP is an equipment that can communicate wirelessly. Therefore, it can provide a more flexible communication for us. So, how do they connect together? As we can see, XP is acts as the centers of the Arduino and the PC. XP can receive the message from Arduino or PC and can send back to each other in order to let the Arduino and the PC communicate. Then we would like to use different API frame to send out command signal. At this stage, we have used frame 10 to transmit requests, frame 8 to send out AT command, and frame 91, which is the received frame from frame 10. The format of the frame is similar. We have a start delimiter and the length indicates the frame type and can send out the RF data, just like this is the frame type, and it would be the RF data which represented in ASCII code. Where the RF data is the main part to decide what to do. Then we would like to talk about the equipment.
In the equipment, we will provide 5 functions of the smart pet host. The first function is food feeding. Food feeding introduces 2 parts of the food feeding machine, which are the function of providing the food and the other function of checking the storage of food. In this project, we will provide the apps for the user to control the smart pet host. Then the user can log in the system. Here we can see the home page. He can choose paid or free. In this case, the user chooses feed. Then we will provide the information of the feeding history and the button Start Feed. After the user clicks the button, then the server which is installed in the home will receive the signal and send out the control signal through the Arduino and XP. The food machine will work and provide the food. For the other function, when the storage of food decreases into a very low level, the machine will send out a signal to the server, and the server will receive back the message, will send back the message to the user through the app communication. It will jump out a pop-up window in the home page and notice the user that that there isn't enough food in the food machine. Secondly, for the water refilling part, this is the water supply in the doghouse. The most important thing is that the water can be automatically refilled without any human control. In this project, we will install the water sensor into the water bowl. When the sensor senses the water level of the water bowl is low, the Arduino will send out the control signal and ask the water pump motor work. Then the water pump will pump the water from a large scale of water bottle storage to refill the water in the water bowl. And the Arduino will send out a message to the app to notice the dog owner. The water bowl is just refill the water. For the third part, it is a toys. In this project, we will create a mini dog toys for the dog entertainment. Here we will build up a mini system for throwing dog ball. In the application, the user needs to choose play in the home page. Then it shows 6 buttons in the page. For example, when the button 1 is clicked, the server will receive signal and send out the signal to the Arduino. The Arduino will open the gate of the box 1. Then the 1 ball is thrown out by dropping down the ball from the holder. The holder totally gets 6 balls, but we may only demonstrate 1 box in the future, and the holder will install on the wall. The fourth part is toilet. For the most of the case of the dog owner, they will use the housebreaking pad as the dog toilet in the home. When they leave the home, the housebreaking pad will just put on the floor. In some cases, they may have a plastic hold for keeping the housebreaking pad in a fixed size. In this project, we are going to introduce an automatically dog toilet for the dog owners who has the habit of using housebreaking pad as the dog toilet. In this project, the toilet is combined with 2 main parts of modules. The first part of the module is a sensor to scan the housebreaking pad directly. When the dog shit is occurred, then the sensor will output the signal to the client server. The program will run and ask the second part of the modules to function. The second part of the module contain 2 wheels. The 2 wheels will rotate in clockwise and anti-clockwise direction. In the upper wheels, the little housebreaking pad will pull out by the rotating wheels when it drops to the holder platform. The lower part of the wheel will rotate in order to push the housebreaking pad in the right position on the platform. For the used housebreaking pad, which contains some shape, the lower part of the wheel will push it in the opposite side direction to throw out the used pad into the rubbish bin. Then, every time of the user can clean up the rubbish bin directly. And the fifth part, it is a real-time camera. One of the concerns of the dog owner is that they don't know what happened to the dog when they are leaving. So as to solve the problem, in this project, we will offer a real-time camera and install in the suitable place. The real-time camera can allow the dog owner check the digital video through the internet, which is similar to the CCTV. When the dog owner logs into the apps, it can click the button and ask for checking the video. Then the camera with the client server will send back the instance view through the internet. In this project, we also want to develop some special alarm for the dog owner. For example, when the dog keeps barking in the home, we will send out a message to the owner, like your dog is non-stop barking now. Or when there was a high volume of noise occurs, we will send out a message like your dog may broken some decorations. Here is the experience part. I will introduce the first part is food feeding. In the past 2 weeks, we decided to do the food feeding and the water refilling part first, and we set up the wireless connection between two Arduino. Then the other 3 parts of the modules will be finished in the next semester. Here it is going to introduce the food feeding and water refilling hardware modules. First, for the implementation of food feeding, we need an LED light bulb or a TOF, and we will install it into the machine in the next semester. As we need to do several experiments to decide the best position of the light bulb installed in the machine. Then we will use a photoresistor to be a light bulb sensor to determine there is a light source or not. When the photoresistor can't sense the light, that means that the dog dry food blocked the light in the machine. There is still enough food in the machine. Otherwise, the photoresistor can sense the light on. That means that the dog dry food is nearly empty. The server will receive the signal from the machine and the Arduino will send out the message to the user to notice that the storage of food isn't enough. For the difficulties, we tried to use the IR sensor before, but we found out that LED with the photoresistor is easier to function and work in the machine, and we put lots of time to realize the mechanism of the food machine. And the result, we can know that the received data is on Arduino is higher when the photoresistor receives a lighter light source, and we apply this experience data into the program.
In terms of the water refilling part, we mainly use the ICL293 to upgrade the power of the water bumper, a water pipe, and a water sensor which can connect to the Arduino. First, we connect water sensor to the water bottle, and the water sensor can sense enough water or not. If it is not enough, the water bumper will automatically run to fill the water bottle from the water tank. In these experiments, the difficulties is how to decide the suitable water level, and we need to try to write a program to get the data. And the result is the data amount increase, the data of the value that's showed on the Arduino will increase. So for our future plan, in the next semester, we will have 3 plans. The first plan is to finish the setting of other parts. There are the toys, the toilets, and the real-time camera. Moreover, we would like to improve the recent food machine. Then we need to make all the things connect to the net and design an apps to let the host to control the equipment. And that's all of our final year project present. Thank you.